All right, so ladies and gentlemen, here we go. We got chapter 2, 8.2, day 2 notes, a little factoring. So that's our goal. You should be able to use the GCF and the distributive property to factor polys. Okay, so if we take a look, remember the old distributive property. You guys remember that? Back in the day, distributive property says I take A times the quantity B plus C. I got to distribute that A to each term. So A times B is AB and A times C is AC. So that's kind of what we're doing today is we're going to do the distributive property but backwards. And that's called taking out the GCF. So when we look at this polynomial, or I'm taking this monomial times this binomial, I'm going to take this 3 times A, that's 3A, and 3 times B, that's plus 3B. Well, now we're going to go backwards. We're going to look at 3A plus 3B, and we say, what's the GCF of 3A and 3B? What do they have in common? What do you guys say? Ivan's given me the 3 symbol. And now, if there's 2 terms here, guys, we're going to have 2 terms here. Well, what's 3A divided by 3? That's just A. And then plus 3B, if I take the 3 away, that just leaves me with plus B. Okay? Now, the nice thing is you can check your work with the distributive property. Number 1, look at what's inside and make sure there's nothing in common. And then distribute back in your mind, 3 times A is 3A, 3 times B is 3B, boom, done it. It did. So again, that's the distributor property backwards. So as I take a look, we distribute, x times y we know is xy, and x times negative z is negative xz. So that's the distributive property. Well, finding the GCF is just the opposite. We take a look, we got xy minus xz. What do they have in common? What do they both have? Xy minus xz. What do they both have? They both have an x, right? So we can take that x out. That's called taking out the greatest common factor. So take that x out, and now on the inside, I'm going to have the same amount of terms that I had originally. So here I have 2 terms. I should have a binomial inside. So take xy and remove the x. What's left? Just y. Take negative xz and remove that x, and now I got negative z. Now the nice thing is I always double check. I look on the inside. There is no GCF left on the inside, no common factor. And I can distribute. X times y is xy, and x times negative z is negative xz. You guys good with that? All right, so we do the last one here. Distribute. Whee! What's 3y times 4x? What's 3y times 4x? What's 3 times 4? 12. And x times y is just xy. Always write that in alphabetical order. So you wouldn't write it yx, you want to write that as xy. X comes before y in the alphabet. What's 3y times 2, y'all? Damien? 6y. Very good. Okay. Now we're going to go backwards. Okay? We're going to go ahead and factor out the greatest common factor. So I look. First thing I do is the 12 and the 6. What is the greatest common factor of 12 and 6? What's the biggest number they're both divisible by? Okay, 6. I can take a 6 out. Then I look at the variables x and y. What do they both have in common? A y. All right, now take 12xy and divide the 12 by 6. What's 12 divided by 6? 2. And xy, remove the y, leaves me with just x. And now, if there's 2 terms here, you have to have 2 terms on the inside of this guy. So think about what happens if you take 6y and divide it by 6y. What's 6 divided by 6? What do you get when you take, here's my idea here. What's 6y divided by 6y? What's 6y divided by itself? Gail. What's 6 divided by 6?
Wait.
What's 6 divided by 6?
1. Y.
Yeah, so I think I heard you say it. 6 divided by 6 is just
1.
Just 1. And what's y divided by y? 1. This is equal to 1. Okay, so you got to have a placeholder here. This is a positive 1 right here. You got to have that, you have to have a term there. Okay? And you're looking at, when you factor, you're really dividing it out. Okay? And that way, when I distribute back, 6y times 2x is 12xy, and 6y times 1 is 6y. Okay? Any questions? Now, some of you guys might have done this one, and you had this 12xy plus 6y, and you might have just wrote what they had over there, which was 3y, and then 4x plus 2. And later today, you have IXL, and you're going to type that answer in, and it's going to go, wrong. That is not correct. Why is this not correct? Okay.
Is it because 3 isn't the greatest?
Yeah, 3 is a common factor, but it's not the biggest common factor. Look on the inside of your binomial here. What is 4x plus 2 still divisible by? Yeah, I'm getting the peace sign here. It's still divisible by 2, so I can take that 2 out also. So if I take that 2 out, that's 3y times 2, and then 2x plus 1. Well, that simplifies as 6y and 2x plus 1. Okay, so before you circle or put anything to IXL, double check that there's not still a GCF on the inside. Okay, if there is, that just means you took the common factor, but not the biggest or greatest common factor. All right, so let's put this in action. Let's go. We got a few minutes left. Factor each expression. I have 2 terms to start, so on the inside, I'm going to have 2 terms. So some people like to actually put like little marks here, so they don't forget that there's 2 terms there. All right, so let's take a look. 25a to the 4th plus 15a squared. What's 25 and 15 both divisible by? I'm hearing 5. I'm seeing 5. 5. A to the 4th, a squared, I can take out and, or I can factor out. What do they have in common? A what? How many? 2 of them, a squared. And this marker is dying here. Let me use a purple here. So I've got 5a squared. Perfect. Well, now I'm going to have 2 terms on the inside here, right? What's 25 divided by 5? 5. And if I had a to the 4th and I took away 2 of those, I took away a squared. How many are left? 2 of them. I got an a squared left. You guys okay with that? Plus, all right, 15. I had 15 up here, but I divided out a 5. So that leaves me with 3. And I had an a squared, but I took that out, so I have nothing left. Just 3. And there we go. Do you have any more terms on the inside that are like? People are shaking their heads, so I can circle my answer. Now, I can always double check. If I was to distribute back, 5 times 5 is 25. A squared times a squared, I add those exponents, that's a to the 4th. 5a squared times 3 is 15a squared, so I know I did it right. Easy peasy. That's right. All right, let's take a look at the next one. I got 2 terms. Boom, boom. So when I take out my greatest common factor, I'm going to have 2 terms inside. I look at 18 and negative 12. What are they both divisible by? What's the biggest number, Damien? 6. I can take a 6 out. Very good. Now I have an x squared and an x cubed. What's the most amount of x's I can do? If you're not sure, write them out. And then circle. Well, this one has 2 and so does this one, right? There we go. That's x squared. You guys good with that? All right, what's left? If I have 18x squared and I just divided out a 6x squared, what's 18 divided by 6? 3. And I had x squared and I took out x squared, so there's no more x's to worry about. All right, that's a minus 12, so that's minus. What's 12? What's negative 12 divided by 6? 2, so minus 2. And then I had x cubed and I took away an x squared, so I took 2 of those away. What's left? Just an x. And there we go. Making sense or not making sense? Now, if you need your factor trees, guys, I mean, if you're at 18 and 12 and you're like, I don't know what they have in common or what the biggest number is, well, you guys can also go off to the side and say, okay, well, 18 is 2 and 9, 3 and 3, right? And then 12 is 2 and 6, and I'm out of room, I'm right over here, 2 and 3. Well, I got a 2, and I got a 3 in common. 2 times 3 is 6, so now I got my GCF. So if you need to go off to the side, use your factor trees. If not, it's probably starting to come pretty clear on what those factors are. So, all right, let's make it harder. Now, instead of binomials, we got trinomials. So again, I'm going to have my GCF, and I'm going to have 1, 2, 3, 1, 2, 3 terms. Always, 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 you should have the same amount of terms as you start with on the inside of your parentheses. Now I look at 6, 24, and negative 30. What are they all divisible by? What are they all? Well, 6. I can take out a 6. That's divisible by 6. That's divisible by 6. And negative 30 is divisible by 6. Then I look at my a's. I got a cubed, a squared, and a. The most I can take out from all three is just an a. You guys okay? All right, what's 6 divided by 6? 1. I take an a away from a cubed. How many a's are left? There's 2 of them, a squared, right? Plus. What's 24 divided by 6? 4. I have an a squared and I took out an a. What's left? An a. 1a. And I got negative 30 divided by 6. That's negative 5. And I took that a outside, so it's already good. Now, for me, I prefer if you write it like this. Instead of 1a squared, we got to get used to saying just a squared, guys. 1 times anything is anything, right? So 1a squared is just a squared. Let's stop writing it as 1a squared. So final answer. Inside, if I look at all 3 terms, there is no GCF that I could take out. And I can always check my work on this. That times that is that. That times that is that. Yes. All right. There is no GCF, and I checked it. All right. Any questions, y'all?